بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. Hello dear students, I hope you are doing well. Welcome to a new lesson on the Inspire Chemistry series. I'm Mr. Muad, and inshallah we'll be going through the second lesson of Module 14. But before that, just a gentle reminder for everyone, please share and subscribe to the channel. Share it with your friends, with your classmates, and help us reach our first 1,000 subscriber. If you do so, many of your friends throughout the country are going to hopefully benefit from these videos. Okay, thank you. So we are continuing on our Inspire Chemistry series. We are going to continue on Module 14, Lesson 2. Last time we talked about Lesson 1, which was energy in general. Remember? Chemical potential energy and types of energy and so on. So now we'll focus more about heat, okay, which we solved questions about last time. So remember we talked about the definitions of endothermic and exothermic reactions, okay? So what is energy, or what happens to energy? So energy is conserved in a chemical reaction. Remember, قانون حفظ الطاقة, which is the first law of thermodynamics, that we cannot create or destroy energy. So the total energy before a reaction is the same one after the reaction, okay? And I told you that endothermic means you absorb heat, يعني تمتص الحرارة, and exothermic means تطلق الحرارة, okay, أو تفقد الحرارة. All right, so the energy or the heat is going outside. So X from exit, outside, in from inside, endo, يعني للداخل. All right. So what do we want to learn from this lesson, from lesson 2? So after this lesson, you can, hopefully inshallah, describe how a calorimeter is used to measure energy that is absorbed or released. So we have been talking about energy, right? But how can we measure it? What helped us to measure energy, okay? So we'll learn about the calorimeter, perform different calculations in a calorimetry experiment. So what are the calculations we use when we use the calorimeter to measure heat? And we'll explain some definitions that will help us throughout the remainder of the module, such as enthalpy change of a reaction, and so on. So don't worry about these keywords. We will learn it inshallah in the second part of this lesson. So for part 1, guys, we are going to focus on the first 2 learning objectives, okay? So the calorimeter, all right? So how are heat and temperature related? So heat اللي هي, all right, heat اللي هي الحرارة, all right, and temperature is درجة الحرارة. So there is a difference, okay? Heat here is energy, okay? So what's the idea or the main idea of this lesson? The main idea is that the enthalpy change for a reaction is the enthalpy of the products minus the enthalpy of the reactants. So final minus initial, after minus before. And we will see what do we mean by enthalpy, okay? So don't worry about this right now. And what is calorimetry? Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. So if I have a chemical reaction, يعني تفاعل كيميائي وأريد أحسب كمية الطاقة الحرارية التي فقدت أو اكتسبت, we use a process called the calorimetry, okay? From calories, all right? So, and metry is قياس, okay? So, going back to calories, if you remember last time we talked about calories with the capital C and calories with the small c and joules and so on, right? So how many calories are in the presented food? For example, let's say if you look at this sheet, the nutrition facts, when you buy anything from any supermarket, you can find this nutrition fact and you'll find how many calories are there. So how many calories can you see? 60 calories, right? So 60 calories, or actually this should be 6 kilocalorie, okay? Because remember, we said that, sorry, it's 60, my bad. Let me erase this. Remember, we said that 1 capital calorie is equal to 1000 small calorie, okay? So the main question here is, how did we know how many calories are in the food? How did we measure this 60? Where did we get this number from, guys? This is the main thing, okay? So we actually use the device called the calorimeter. جهاز يسمى الكالوريميتر, okay? هو اللي ساعدنا إن نحسب هاي القيمة. So what's a calorimeter? We'll see that in the next slide, okay? And these are the important keywords for this lesson, just for you to appreciate them and know them. So we are going to see all of these in the slides, okay? Inshallah. And very important for you to remember, how do we measure heat, okay? So Q is equal C, which is the specific heat, okay? And M is the mass, and delta T is T final minus T initial. Okay, this was from lesson 1 اللي أخذناها في الفيديو اللي فات. Okay, so what's a calorimeter? So a calorimeter is an insulated, يعني عازل, insulated device أو معزول, okay, used for measuring the amount of heat, the Q, okay, absorbed or released during a chemical or a physical process. Okay, so it helps us, this device helps us measure Q, okay, get a number, all right? So this is how it looks like. We have two types, or the main types are bomb calorimeter and coffee cup. So here in your book you have the bomb calorimeter shown in this image. So inside here we have water. This item here is an insulation, عازل حراري عشان الحرارة ما نفقدها تطلع برا. There is a thermometer to measure temperature. Okay. There are ignition terminals that will help ignite fire. Sealed reaction container. So here you are going to put, or here is where the reaction will happen, inside this place. Okay. So we burn things inside here, and then we measure the energy or the heat they will release, because the heat that is released is going to go to water, and the temperature of water is going to increase, and then the thermometer, the reading in the thermometer is going to go up. So actually what we measure here, the only thing we can get, or the data from here, is actually temperature. So what we can read from this device, we cannot read energy. ما نقدر احنا نشوف الحرارة بالجول، لا احنا بس نقدر نشوف التغير في درجة الحرارة. So we can get delta T, because the temperature was here like T initial, and then it will go up, it will become T final. So we can get delta T, and we know the famous equation, right? Q equals Cm delta T. So we have delta T. We know how much mass we added here. We know the specific heat. Okay, but I'm going to show you how we use it properly. But we actually get the temperature from this device, and then we use it in this equation. هذه بطريقة مبسطة كيفية استخدام البومب calorimeter, right? So I'm going to show you a video here that shows you best how is this device, or how does this device work. Okay, I'm going to share the link for the EduShare here down in the description of the video. Okay, so basically this is the bomb calorimeter. All right, in here we put what we want to, like the food that we want to measure the energy from, or the reaction that we want to study. Okay, there's water, there's a stirrer, there's a thermometer. So we ignite here, we burn the food, or we burn the reaction starts, and then the temperature of water will increase لأن الحرارة تنتقل من هني للمي، فدرجة حرارة المي تعلى, right? So we read the difference in temperature. So when we read the difference of temperature, we use it in this equation. So we know the specific heat of water, we know the mass of water, and now we know delta T of water, right? Automatically الحرارة اللي اكتسبها المي تساوي الحرارة اللي أطلقها التفاعل. فإذا حسبنا الحرارة اللي اكتسبها المي هي نفسها الحرارة التي أطلقها التفاعل. So if we measure the heat absorbed by water, it's going to be equal to the heat released by the reaction here inside. And that's how we measure the heat from this reaction, okay? So basically, that's how we use the bomb calorimeter, right? For example, here we have copper inside or whatever the... No, we don't need to go deep into that. I'm going to stop here because I just wanted to show you this part of the video actually, okay? So basically, this is what we want to know, all right? So again, this is the bomb calorimeter, and I'm going to show you how we use this equation in calculations, okay guys? So don't worry about it. But just understand that the calorimeter is used to measure heat absorbed or released in a chemical or physical process, and the data we read from the calorimeter is the change in temperature. في فرق ما بين هو يساعدنا على حساب الحرارة، لكن هو شو يقيس؟ هو يقيس درجة الحرارة عشان نستخدمها في الدلتا تي في الإيكويشن حقت الكيو. شفتوا الفرق؟ So just mind that in your mind. Just be careful about that or concentrate on that. So how is it used? As I told you, a known mass of water is placed in an insulated chamber to absorb the energy released from the reacting system or to provide the energy absorbed by the system. So you know the mass of water that you add, okay? The data to be collected is the change in temperature of this mass of water, اللي هي الدلتا T, as I told you, okay? اللي نشوفها في مقياس الحرارة in Celsius. You can use a calorimeter. What are the uses of calorimeter? To measure the Q, and you can use it to determine the specific heat of an unknown metal, اللي هي C. All right? How can we do this? We are going to see it also in the next slides, okay? Now, this is a second type of a calorimeter. So what we have been seeing is the bomb calorimeter. Now we are going to see a simpler form of the calorimeter, which is called coffee cup calorimeter, all right? So it has water inside. It has a thermometer. This is like an insulator. Okay, الفلين يعني ما يوصل حرارة أو يوصلها بطريقة ضعيفة جدا فما نفقد حرارة وايد. So imagine I put a very hot piece of metal inside water. I have this metal, right? This is a metal, معدن. I want to calculate C. I want to calculate C, the specific heat. So how can I do that? We are going to see it, okay? So, as the figure shows you here, an initial temperature of 25.6 degrees is recorded for 125 grams of water in the calorimeter. This is A. This is A. لسه ما ضفت قطعة المعدن. Alright? So this is T initial of water. And this is the mass of water. Okay? This T initial of water. So W, I mean by it water. Okay? B, in B, a 50 gram sample of an unknown metal, معدن غير معروف. So this is the mass of the metal. So M, so met is for metal, okay? This is the mass of the metal, an unknown metal, is heated to 115 and placed in the calorimeter. So this is the temperature initial of the metal. يعني توني حضيفها inside. فدرجة الحرارة الأولى تبعتها. طبعا هي حتكون سخنة والمي بارد فهي حتفقد حرارة والمية حتكتسب حرارة، صح؟ The metal transfers heat to the water, right? Because it's hotter, because the metal is hotter than water. Until the metal and water are at the same temperature. لما يكون عندهم يصيروا نفس درجة الحرارة خلاص لا أحد منهم يفقد حرارة ولا الآخر يكتسب. So the final temperature, so this is the temperature or the T final of water and the T final of the metal. يعني درجة حرارة المية ارتفعت، كانت 25 صارت 29 لأنها اكتسبت حرارة، ودرجة حرارة المتل قطعة المعدن كانت 115 وصارت 29 لأنها فقدت حرارة، بس درجة الحرارة النهائية بتكون متساوية. Okay? So what do we want from here? We want to calculate the C specific heat of an unknown metal. That's one of the uses of the calorimeter. So we don't know المعدن هذا مين, but if we calculate its C ممكن نروح للتيبلز، لو تتذكرون التيبلز من lesson 1 ونقدر نعرف مين هو هذا المعدن. We can know which metal is this. Okay? So what we do, we calculate the heat gained by water because water will absorb heat. Okay? And we know the specific heat of water, the C of water. Okay? So Q of water equals C water ضرب M water ضرب delta T. صح؟ So this is C, this is the mass of water اللي هي 125 جرام ضرب delta T, T final minus T initial. Right? So you get your value here. Notice that this is positive, guys. Why? Because it's absorbed endothermic. Okay? لأن المي اكتسبت حرارة فتكون قيمة الحرارة أو الانرجي بالبوزيتيف أو إشارتها البوزيتيف. إذا فقدت بتكون بالنيجاتيف. Okay? Very good. So now we know the amount of energy absorbed by water, and that's going to be equal to the amount of energy lost by the metal. So the heat gained by water equals the heat lost by the metal. So you can write this equation. Q of metal equals Q of water, and Q of metal is going to be in minus. Why? Because the metal lost heat لأنه فقد طاقة حرارية فتكون العلامة بالماينس. And now you can write this equation. Okay? So what we want from here is C. صح؟ فنقسم هني على M ضرب دلتا T ونقسم هني على M ضرب دلتا T. طبعا which M are we talking about? We are talking about M of the metal and delta T of the metal. Okay? Not water. So M of the metal is 50 grams. Where did we know that? They told you 50 grams of unknown metal. Okay? And delta T is T final minus T initial, which is minus 85.7. So we put the numbers, M and delta T, we put them down here, and we have the Q, we put it up here. يطلع معانا الناتج 0.453. So that's the C of the metal. Okay? And we can go to the table from lesson 1 and search and find which metal or element is that. Okay? So sorry about that, just checking the audio. Yeah, that's how we can calculate the specific heat of an unknown metal using the coffee cup calorimeter. Right? Another question. A piece of metal with a mass of 4.6 grams, 68 grams absorbs 256 joules of heat when its temperature increases by. So when you see increases by or decreases by معناها هذا الرقم هو delta T. So increase by or decrease by means delta, يعني final minus initial. Final minus initial. Okay? So this is delta T. What is the specific heat of the metal? So they want the specific heat of the metal. So if we focus, what they want is C. Okay? So this is what we know. We know the mass of the metal, we know the Q, and we know the delta T, and we want C. So this is similar to the questions in lesson 1. Okay? You just write the equation, for measuring heat. Q equals C times M times delta T, and then you get the C, all right? And that's going to be Q divided by M times delta T. Put your numbers, and then you get your answer. So from table 2 in the book, go and search which metal has a C value of 0.301, and you'll find that will be strontium, okay? All right. As you can see here, strontium. Okie dokie. All right. Okay. This is going to be the last problem in part 1 الجزء الأول من lesson 2. So a scientist heats up an unknown metal block with a mass of 132 grams to 116.5 and places it into a coffee cup calorimeter. So this is before the cup or the coffee cup calorimeter. So this temperature is the initial temperature, and this mass, so this is let's say Ti of metal, and this is the mass of the metal, right? The temperature of the water inside the coffee cup calorimeter rises ترتفع from 2. So this is Ti of water, and this is T final of water. As the water absorbs 4,978.96 joules of heat. So this is Q of water. Calculate the specific heat of the unknown metal. So they want specific heat of the metal. Okay. So what do we know? What do we know here? We know the mass of the metal, which is 132 grams. We know delta T of the metal, which is T final minus T initial. الحين T final of the metal is going to be what? It's going to be the same T final of water. Remember from the last example that we had in the previous slides? That will be 32.5 minus 116.5. Okay? So 32.5 minus 116.5, and that is minus 84 degrees Celsius. Okay? Now for water, we know Q of water, which is equal to 4,978.96. We know the mass. Do we have the mass of water? Did they talk any about the mass of water? Nope. Do we know the delta T of water? Yes, it's going to be 32.5 minus 24. That is 8.5 degrees Celsius, right? Now, what do they want? What's the unknown here? The unknown is the specific heat of the metal. So, very important thing that you should do, you should write the equation to find the specific heat of the metal. So we know that Q metal equals C metal times the mass of the metal times delta T of the metal, right? So C of the metal is going to be equal to Q metal divided by the mass of the metal times delta T of the metal, right? So this is the equation. Now, you should notice that from the known things, what do we have? We have the mass of the metal and we have the delta T of the metal. What we are missing is the Q of the metal. But remember, this is a coffee cup calorimeter. So الحرارة اللي فقدتها القطعة المعدنية تساوي الحرارة اللي اكتسبها المي. المي كم الحرارة اللي اكتسبها؟ So Q of water is going to be equal to Q of the metal. or we can just to do it in a better way, okay, just to make more sense. So the Q of the metal is going to be equal to minus Q of the water، لأن المي اكتسبت حرارة فهي positive، لكن القطعة المعدنية فقدت حرارة فلازم تكون بالنيجاتيف. So actually now the C metal is going to be, so here if we add Q metal, it's going to be minus 4,978.96 joules. Okay, so C metal is going to be 4,978.96, okay, divided by the mass, which is 132 times minus 84. الماينس تتكنسل مع الماينس لأن قيم السي دائما لازم تكون بالبوزيتيف. okay, so this is 4,978.96 divided by 132 times which is going to be 0.449. Now let's go back to the table. Which one has a value of 0.449? That is iron. Okay, هذه وحدة قياس السبيسيفيك جولز over gram times Celsius. ليش؟ لأن هاي وحدتها جولز والماس وحدتها جرام والدلتا تي وحدتها Celsius. Alright, so this is how we do it. And that's the end of the first part. Okay, now we are going to go to the second part, okay, which does not talk about calorimetry anymore, but it talks about chemical energy and the universe. So here we are going to establish or learn about some keywords, important keywords, important terminologies that we are going to use in our next lessons. Okay, these slides are very important لأنهم هم وحدة أساس الدروس الجاية عشان نفهم معنى الكلمات ومعنى المفاهيم. Alright, so let's talk about thermochemistry، الكيمياء الحرارية. في فرع من فروع الكيمياء اسمه الكيمياء الحرارية. Okay, and what is thermochemistry? It's the study of heat changes that accompany chemical reactions and phase changes. So if we study the chemical reactions, okay, and we study the heat absorbed or the heat released from chemical reactions or phase changes. Phase changes معناها تحولات المادة، okay، اللي هي من سائل لصلب، صلب لغاز and so on. Alright, if we study that, it means we are studying thermochemistry. Alright, so remember, heat changes meaning the system or your reaction can release heat، يفقد حرارة، أو إنه يكتسب حرارة، endothermic. Alright, so keep that in your mind. So heat leaves the system here, exothermic, see, it's out, and heat enters the system, so it's endothermic. Okay, so let's go through the keywords, the important keywords in your book. Okay, so what is a system? When I talk about a system, so a system is the specific part of the universe that contains the reaction or process you wish to study. So if you have a big universe here, right, and your reaction happens in this place we call it the system. Alright, because this is where your reaction is happening and this is the place you want to study the reaction at. Okay, what's the surroundings? Surroundings are everything else other than the system. So everything outside here, outside the circle, is called the surroundings. Okay, now if I have the system plus the surroundings, what will I call this? I call it the universe. Okay, So the blue thing here inside this beaker is called the system. So the beaker is my system. I want to study the reaction, like I want to study the reaction inside of it, right? Anything outside this beaker in blue is called the surrounding. الأشياء اللي برا هني البوكس. Anything outside it, okay? And the universe is the system plus the surroundings, all right? So keep that in your mind. You can repeat this part of the video again if you did not understand, okay? All right. So the chemists are interested in changes in energy during reactions. So we want to know if a reaction is exothermic or endothermic. Does it absorb heat or does it release heat, all right? So the energy released or evolved from reactions carried out at a constant pressure is sometimes given the symbol QP. So we are talking about heat here, okay? ثم لما نتكلم على الحرارة اللي تفقد أو تكتسب في التفاعلات الكيميائية ولما يكون الضغط الجوي أو الضغط ثابت ما يتغير نسمي الكيو هاي QP. What does P mean? P comes from the word pressure. The P from pressure. It means that it's a constant pressure, okay? ثابت. Now, remember the word enthalpy, which we saw in the learning objectives and the keywords? So what is enthalpy? What do you mean by enthalpy? It has the symbol H. Enthalpy is the heat content, المحتوى الحراري, يعني كل المحتوى الحراري of a system at a constant pressure. So, if the pressure here is constant, okay, then H, or the enthalpy of this system, is going to be the heat content of the system. Okay, الحرارة اللي موجودة داخل السيستم. Okay, طبعا هالحرارة ممكن تكون حرارة initial or final, right? في حرارة initial وفي حرارة final. So, enthalpy or heat of reaction. What is this? It's the change in enthalpy during a reaction, symbolized by delta H. So when we see the word change, we know it is delta, right? Final minus initial. صح? So H alone, we cannot calculate it. We can only calculate delta H. We cannot calculate H alone. We can only calculate delta H, okay? Before and after. So delta H of Rxn is equal to H final minus H initial, or H products minus H reactants. طبعا احنا نعرف البرودكتس والreactants اللي هم النواتج والمتفاعلات في التفاعل الكيميائي. Alright? So when you see the word Rxn, okay, it means we are talking about a reaction, a chemical reaction, تفاعل كيميائي. Alright? So the enthalpy of a reaction is called delta H reaction, and it's the change in enthalpy during the reaction. Alright? Again, احنا بس الحين قاعدين نتعلم terminologies and equations, alright? And enthalpy is the heat content, okay? It means it's energy. So, exothermic and endothermic. Which one will have a negative enthalpy change? So, which one is going to have a delta H less than 0 and Y? مين السيستم هني اللي راح يكون عنده الدلتا H بالماينس or less than 0? Also, which one will have a positive enthalpy change like delta HRXN greater than 0 and why? So you can pause the video and try to think about these questions, okay? So actually, to answer this question, you need to learn or remember the equation. So delta H reaction is final minus initial, or products minus reactants, right? So the exothermic is going to be negative. Why? Because the system loses energy, it loses heat. So before it loses its heat, before it loses heat, it has more energy. After it loses heat, it has less energy. So H final minus H initial is going to be negative. Okay. On the contrary, endothermic is going to absorb energy. تمتص حرارة. فالحرارة النهائية أعلى من الحرارة في البداية. So final minus initial is going to be positive. Okay, and that's the reason why. So enthalpy changes for exothermic reactions are always negative. So exothermic reaction, energy is released out of the system. So you lose energy. So the delta H reaction is negative. Okay, this is what we saw in the previous slide. Now, enthalpy change for endothermic reactions are always positive. Why is that? Because the energy is absorbed. Okay, it means the delta H is going to be positive. Now, why is this? Because H final is less than H initial. الحرارة في النهاية أقل من الحرارة في البداية. So H final minus H initial بتكون أقل من صفر. بتكون الإشارة بالنيجاتيف، تطلع الناتج بالنيجاتيف. That's why the delta HRXN is going to be negative. على عكس الاندوثيرميك تمتص حرارة، فال enthalpy final is greater than enthalpy initial. So H final minus H initial is going to be greater than 0. عشان شي الدلتا H تطلع معانا بالpositive. Okay, so endothermic the enthalpy change is positive, exothermic enthalpy change is negative. Okay, now how can we use that in real life situations? Okay, you have this picture in your book, and this is a heat pad. Okay, do you know anything about heat pads? And what are they used for? Okay, so it's when there's cold, okay, or you have your you have pain in your back, for example, or when it's really cold and you want to heat up your hands, okay, you can put it inside the jacket or something, right? So do you think they release energy or absorb energy? So they are called heat pads. معناها راح يسخنوك ولا يبردوك? Of course, they're going to heat you up. So are they going to release, يطلقون حرارة ولا يكتسبون حرارة? So the reaction inside is going to release heat. Okay, so as you can see here, now this is the heat pack reaction. So inside of the heat pad there is a chemical reaction happening. Okay, so basically this is the chemical reaction. Okay, these are the reactants, and this is the product. So you have iron and oxygen, they will produce iron oxide. Okay, now notice here, this is the HI. This is the reactants اللي هي الحالة الأولية. Okay, and this is the product HF. So which one is bigger here, HI or HF? So HI is bigger than HF. So HF minus HI is going to be less than 0. صح ولا لا؟ أقل من صفر اللي هي هاي الدلتا H. صح؟ That's why you will find the delta H here is going to be negative. And the heat is released out. تفقد حرارة. So the reaction is exothermic. So if you find reactants above and products below, it means it's exothermic. لأن حتكون حرارة البرودكتس أقل. فالدلتا H بتكون بالنيجاتيف. So that's why it's exothermic. Okay? And I'll let you read the description of this figure here. Now if we have the opposite situation, okay, for example, لا قدر الله, if there's an injury while playing sports or something, we put cold packs, right? Now, cold packs, they will absorb heat from you. Okay, so they will absorb. So this is the reactant. Look, the HI is down here and the product is up here. So the HF of the product is greater than the HI. of the reactants. So delta H اللي هي ال F minus initial is going to be positive, and heat is absorbed into the system. So the process is going to be endothermic. Delta H is bigger than 0 معناها إن هي positive, as you can see here. Alright? So I'll let you read the description again here on your own. Now, can you try and solve this question on your own? I want you to pause the video, okay, and try to answer this question. From this figure 15.23, is this reaction here endothermic or exothermic, and why? How do you know? So, thank you for those who stopped the video and tried to answer. Hopefully your answer is going to be correct. So again, there are 3 ways to know. The first thing is to see the delta H. Look here, is it positive or negative? So delta H is actually greater than 0, positive, صح? So automatically لما delta H تكون positive معناها endothermic. If they did not give you delta H here, look at the products and reactant. Here's HF and here's HI. The final minus initial. So HF is bigger than HI, صح? So delta H, which is HF minus HI, is going to be greater than 0 لأنه الF البرودكتس أعلى من الI. Since it's positive, it means it's going to be endothermic. Alright? So this is the reason why. Okay? Is the heat flowing out of the system or into the system? So لما قلنا endo معناها inside the system absorbs ولا release? So endo from inside, يعني into the system. Okay? So into the system because it absorbed energy. تمام? And these are like this is the last part of the lesson. Now we are going to go through some questions to summarize what we studied so far. Okay? So which equation here defines enthalpy of reaction? Enthalpy or heat of reaction? Is it this one? See? No, this is just heat. Is it delta HRXN? Yes, but we have 2. Reactants minus product and products minus reactants. طبعا احنا قلنا it's going to be products اللي هي الفاينل minus initial اللي هي reactants. النواتج ناقص المتفاعلات. Okay? So this is our answer. So the enthalpy change of a reaction delta H is negative. What does this indicate about the chemical potential energy of the system before and after the reaction? So if you have a delta H that is negative, which of the following is true about the energies before and after the reaction? لو هاي negative معناها مين اللي أكبر؟ الenergy before the reaction or after the reaction? So of course, before the reaction is going to be bigger because the delta H is negative. Okay? So remember, delta H is final minus initial or after minus before. ممكن في الامتحان يلعب لكم بالكلمات initial final products reactants after before كلهم معناهم نفس الشيء. Okay? Just for you to know. So because of that, because the delta H is negative, it means that H initial or before is greater than the one that is after or the final one. A very important point for you to know, the enthalpy change or delta H is equal to QP. Remember QP, which is the heat gained or lost in a reaction carried at a constant pressure. Why is that? Not why is that, sorry. I mean in your book, because all reactions presented in the textbook are at constant pressure, you might assume that Q is equal to delta HRXN. تمام? Just for you to notice this. Sometimes in the book they are going to use the value of Q as delta H reaction because it happens at a constant pressure. Okay, final summary, final questions before we finish our lesson. What is the name of the insulated device that is used to measure the amount of heat absorbed or released during a chemical or physical process. طبعا احنا قلنا to measure heat absorbed or released we use the device called calorimeter. Okay? Which of the following best describes what is studied in thermochemistry? Is it physical changes? No. Phase? No. Temperature? No. We said thermochemistry is a study of heat changes. التغيرات الحرارية. Which of the following is not true about enthalpy? Not true. يعني الشيء اللي مو بصح على الانثالبي هني هو اللي بنختاره. The actual enthalpy of a substance cannot be measured. Remember when I told you we cannot measure H? We can only measure delta H. So yes, this is a true statement. It is represented by H. Yes, that is true. Enthalpy is actually H. It is a measure of temperature. No, this is not a measure of temperature. It's a measure of heat changes, right? So this is going to be our answer. It is the heat content of a system at a constant pressure اللي قلناها قبل شوي. QP is equal to delta H. صح? So yes, this is true. So all of these are true except this one. It's not a measure of temperature, it's the measure of heat changes in a chemical system. The chemical reaction that occurs in a heat pack is exothermic. What is true of the enthalpy change for this reaction? So what is true? Enthalpy change معناها delta H. هل الدلتا H بتكون 0 ولا أقل من 0 ولا أكثر من 0؟ Remember إحنا قلنا exothermic معناها delta H is less than 0 negative لأنها تفقد حرارة صح؟ So it's going to be less than 0. So we reached the end of our lesson. So in this lesson you learned how to describe how a calorimeter is used to measure energy that is absorbed or released. We performed different calculations in the calorimetry experiment, remember? The piece of metal and water. And we explained what do we mean by enthalpy and enthalpy change in chemical reactions and endothermic and exothermic. Okay? So thank you very much, guys. I hope you will benefit from this video. Again, please don't forget to share and subscribe to our channel and help us reach our first 1,000 subscribers. And if you have any comments or anything, you know how to reach me and contact me. You can also use the comments section on YouTube. And again, please try to share this channel and subscribe to it so that many of your friends can benefit, inshallah. Okay? So I wish you all the best and see you in the next video, inshallah.